a simple introduction to the Pythagoras theorem. So, what is the Pythagoras theorem? Well, the Pythagoras theorem is a fundamental principle in geometry that applies to right-angled triangles. It states that in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. While this might sound complicated, it's actually pretty simple if we break it down. So, what is a hypotenuse? Well, a hypotenuse is the longest side of a triangle, and it's always opposite the right angle. So in our triangle over here, this is our right angle, so the side opposite is our hypotenuse, and we always call our hypotenuse C. Then we have two other sides, A and B, and it doesn't really matter which one's which. Basically, what this theorem tells us is that if we know the lengths of two sides of a right angle triangle, we can always find the third. And this rule is represented like this: a squared plus b squared is equal to c squared. But why does this theory work? To answer that question, let's have a look at this diagram. The first thing we can see is a right angle triangle, the pink one in the middle. So let's go ahead and label the sides: A, B, and C. We can also see that each side of the triangle corresponds to a square. And we know that the formula to find the area of a square is the side length squared, as we can see here. Basically, to prove the Pythagoras theorem, we have to find the areas of the squares. So let's start off with the square that corresponds to side A. 3 squared is equal to 9. Then B, 4 squared is equal to 16. And then C, 5 squared is equal to 25. Now we just need to plug these values into the formula. So our formula, a squared plus b squared is equal to c squared. So 9 plus 16 is equal to 25. And 9 plus 16 is 25. So we can see that the theorem is true. Now we're going to have a look at an example to understand how we can use the Pythagoras theorem to find a missing side. But before I start, I'm going to write out my formula. A squared plus b squared is equal to c squared. And I'm also going to label the sides of my triangle. So A, B, and C. Now let's have a look at the question. XYZ is a right angle triangle. XZ is 8 centimeters and ZY is 15 centimeters. Calculate the length of XY. So all we need to do to solve a question like this is plug in our values into the formula. So A is 8, so 8 squared, plus B, which is 15, 15 squared, is equal to C squared, because we're trying to find C. Now let's get our values for these numbers. So 64 plus 225 is equal to C squared. Now we add these numbers, so 289 is equal to C squared. And the last step is to square root both numbers. So square root. C is then equal to 17. And let's not forget the units, 17 centimeters. And that's our answer. Now we have some practice questions, so feel free to pause the video and try these out for yourself. So all we need to do is plug in our values into the formula. So x squared, which is our C, is equal to 9 squared plus 12 squared. Turning these into values, we have x squared is equal to 81 plus 144. We now add the numbers, so x squared is equal to 225. And then the final step is to square root both sides. So square root, and we get our answer. X is equal to 15. Now question number 2 is a little bit different because we know our hypotenuse, but we're missing one of our side lengths. However, the approach is the exact same. So we plug in our numbers. 17 squared is equal to 15 squared plus y squared. Then we turn these into numbers. So 289 is equal to 225 plus y squared. And now we need to isolate the y, so we take away 225 from both sides. And we're left with y squared is equal to 64. And then we square root both sides. So y is equal to 8. And that's our final answer. Here we have another practice question, so feel free to pause the video and try it out for yourself. So we need to calculate the height of the triangle, which is marked by this line over here. The first step is to find a right-angled triangle in order to be able to do Pythagoras. So we actually have a right angle here and a right angle here. So let's copy down one of these triangles, our right angle, and then our 10 centimeter hypotenuse. But we need another side length, and we can actually find this by dividing our base by 2, because we took half our base and have it over here on our triangle. So 6 divided by 2 is 3 centimeters, and now we just do Pythagoras as usual. So 10 squared is equal to 3 squared plus b squared. 100 is equal to 9 plus b squared, and then minus 9 minus 9, so 91 is equal to b squared. And now we just need to square root both sides. So square root, square root. And 91 actually can't be simplified any further, so the final answer is just b is equal to square root 91. And we leave it like that. Here we have our last question. Feel free to try it out by yourself first. So we need to determine whether this triangle has a right angle. And to do this, we just see if the Pythagoras theorem holds true. So we plug in our numbers. 25 squared, which is our c, is equal to 7 squared plus 24 squared. This becomes 625 is equal to 49 plus 576. And if we add these numbers, we can actually see that they also become 625, meaning that our statement is true and that this triangle does have a right angle. Thank you so much for watching. I hope you enjoyed the video. Please like and subscribe. Bye!